Hi everyone, welcome to CodeTav management. So we have covered the S for single responsibility principle of these solid principles. Now we will discuss about the O for open closed principle. Okay. So what is this? So this is basically the software components should be open for the extension but closed for the modification. So simply, we can say like software components like classes, modules, and functions should be open for extension but closed for the modifications. So if we consider our software component as a class, so then classes should be open for the extension but closed for the modification. So in doing so, we stop ourselves from modifying the existing code. So therefore, we also stop the causing potential new bugs in an otherwise happy application. Okay. So the one exception to the rule is when fixing the bugs in existing code. That is the one exception. So we should modify our class only at the time of bug fixing, right? So open to extension means that uh, first part. What is means? So this open to extension or open for the extensions, that means that you should design your classes so that new functionality can be added as new requirements are generated. And this closed for these modifications means that once you developed a class, you should never modify it except to correct the bugs. Okay. So you make the functionality in this way, like you should design your classes. That's why new functionality can be added only when new requirements are generated. And once it will develop, okay, then you will never modify it other than resolving the bugs. This is the main concept for this open closed principle. Open for extensions, but closed for modifications. So these two parts of the principles appear to be the contradictory. So however, if you correctly structure your classes and their dependencies, then you can add the functionalities without editing the existing source code. So design and code should be done in a way that new functionality should be added with minimum or no changes in the existing code. Okay, so when needs to extend the functionality, avoid the tight coupling. Don't use if else switch case logic. Do code refactoring as much as possible. Okay, so how you can extend the class? Mm, so there are several ways you can do by uh, inheriting. So inheriting from the class. Second is overriding the required behaviors from the class. Then extending certain behaviors of the class. Okay. So generally you achieve this by referring to abstraction for dependencies such as interfaces or abstract classes rather than using the concrete classes. So you have to use the interfaces, the abstract classes rather than the concrete classes. So we can add the mm, functionality by creating new classes that implement the interfaces. So this reduces the risk of introducing the new bugs to existing code, leading to more robust software. So I will give you one example that violates the open closed principle. OCP. Okay. So OCP means open closed principles. So let's assume that we have to write a program that calculates the area of the various shapes. So we start with creating a class for our first shape. Let's say rectangle, okay, which has two attributes. One is length and another is width. Okay, so public class rectangle, and there two parameters. Public means two attributes, you can say. Public type is double, and first one is length. Okay, and second one is public double width. Okay, so further we create a class to calculate the area of the rectangle, which has a method calculate rectangle area. So which takes the rectangle as an input parameter and calculates its area. Okay, so for that I'm creating another class. So public class, then area calculator. Then here I will make the method like calculate rectangle area. Double. Mm. So input I am passing the rectangle. Okay. Okay. And there I am just returning the rectangle dot length multiplied by rectangle dot width. Okay. So far, so good. So now let's assume we have to write a program for our second shape, circle. So we promptly create a new class, circle, with a single attribute radius, right? So for that, so that is public class, then circle, and there one attribute is there like public double radius, right? So then we modify the area calculator class to add the circle calculations through a new method. Okay. So what we will do the modifications? We'll modifications in this way. Like this is already there. So then what we are doing? So this is the public double calculate the uh, circle area. So for that, we will pass here the circle, right? And here how we will calculate the area of the circle, like 22 by 7 multiplied by circle pi r square, right? So circle dot radius uh, multiplied by circle dot radius. Okay, in this way we will do. So, however, please note that there are flaws in the way of designing our solution here. So let's say we have a new shape pentagon. So in that case, we will again end up modifying the area calculator class. So as the type of shapes grow, this becomes messier as area calculator keeps on changing, and any consumers of this class will have to keep on updating their libraries which contain the area calculator. So as a result, area calculator class will not be baselined or not the finalized with surety, as every time a new shape comes and you need to modify. So this design is not closed for modification. So here this is given that closed for modifications. Whenever something is developed, you will not modify that one, right? So you can extend it, but not modify. So uh, this is not the closed for modification. So area calculator will need to keep on adding their computation logic in newer methods, and we are not really expanding the scope of the shapes. Rather, we are simply doing bit by bit solution for every shape that is added. Okay, so I'm means this will be here just commented out, and then you need to modify in this way again. So this is violating. Then I am writing for which will follow the OCP. Okay, so follows OCP. How you can modify that one to follow this open closed principle? So uh, just see, like I am using one interface and which is like SIP, right? And here public, um, sorry, double here calculate area. This will be there. And now the mm, the classes will just implement that interface. Okay, so for this one public class, suppose rectangle, right? So for this rectangle, what it will do, it will just implement shape. Okay, and here you will have the double length is there, and you also have double width with you. Okay, and then you will calculate the area. So public double calculate the area. So what you will return here, you will return the uh, length multiplied by width. Okay, so in this way you will just do it, right? So next for the means the interface is same, just the classes will implement that one. Okay, and you will just return that one. Okay, in this way, this is the approach. So for the circle, you will do the same approach, like public class, and then just circle is there, and it will also implements the shape. And then in this you will have the public double radius. Okay, and then public um, double calculate area, and here you will just return written this 22 by 7 multiplied by just radius multiplied by radius, right? So this will be your approach. Okay. So in this way, you need not to modify your interface. You just use that interface, and for proper steps, you can just use your parameters or attributes, uh, and then you can just write your logic in there. Okay. So there is the base interface shape, and all shapes now implement the base interface shape. So shape interface has an abstract method, which is the calculate area. So both the circle and rectangle provide their own overridden implementation of that calculate area method using their own attributes. So if in future we want to calculate area of other shapes like triangle, square, pentagon, so we can implement the shape interface without changing any class. So we have brought in a degree of extensibility, as shapes are now an instance of shape interfaces. So see, previously one method was there, and we were just modifying that one. But here, for each there are each one class, so it also maintains the single responsibility. So this rectangle class is simply just calculating the area of the rectangle. This is the single responsibility for the rectangle class. The circle class, in the same way, there is the single responsibility as well. And we are not making the modifications of any class or methods. Okay. So in this way, so the last point in the consumer of this shapes, the consumer will be the area calculator class, which should now look like in this way. So mm, I'm writing. So here, like public class, like here, this area calculator was there, right? This area calculator. So what we will do? So public class area, uh, area calculator. Hmm. And inside that, public double. So this one will like calculate shape area, and here we will pass this shape, right? Shape. So here we will just return the shape, as that shape means all the classes implementing that shape interface. So that shape dot uh, calculate that area means this method. Okay. And it will be returned. So yeah, so this is the approach. So what are the benefits for that? So you got it, right? So in previous this classes was there, and here we are just using the attributes here, and next in this area calculator method we are just modifying. Okay. But here we are using the interface, and we are implementing that interface in the classes. Okay. And we can write our logics inside there, and there will be the last class, or you can say as the um, base class, so which is save. So all that classes, so save interface, sorry. So all the interface means all the classes will implement that base interface, which is save. So this makes the extensibility. Okay. So in this way. So now I'm going to explain the benefits of OCP. Okay. So easier extensibility. So needless to say, like open closed principle offers a better extensibility to your code when you write your code in such a way that it has no modification and allows extension, you will get better extensibility on its own. Then easier to maintain. So the principles suggest using interfaces, and interfaces in code offers an additional level of abstraction, which in turn enables loose coupling, and the implementations of an interface are independent of each other and don't need to share any code. So hence you can easily maintain your code with clients keep changing requirements. So like first one is like easy to extend. Next one is like easy to maintain. Third one is flexibility. So flexibility means like when you follow the open closed principle in writing your code, so you will have better flexibility to extend it. Okay. So if any change request arises in future, so your code will be more flexible to extend. So these are the benefits for the open closed principles. Next, like there are some limitations, like you want to know like the limitations. So means the pros and cons. So limitation means like whenever we incorporate any change to the code as an extension, we need to do the unit testing before and after implementing the same. So this is the limitation, right? So, but it's a best practice, unit testing, unit testing required. Okay. So what are the design patterns that follow open closed principles? So there are uh, uh, multiple design patterns that help us to extend code without changing it. So design patterns. So this is design principles. This is solid principle is the design principle. So now design patterns which follow OCP means open closed principle. So first one is decorator pattern. So decorator pattern that help us to extend the code without changing it. Like for decorator pattern offers us to follow the open closed principle. Furthermore, we may use the uh, factory pattern. Okay. So uh, then you can say as the strategy pattern. Okay. And observer pattern as well. So decorator patterns, factory patterns, strategy patterns, observer patterns, those follow basically the minimum changes in the existing codes. Okay. So there are some questions you can uh, learn which will help for the interviews. Like how does the OCP help in agile software development practices? So OCP helps in agile practices by promoting the code that is more adaptable to frequently changing requirements. It facilitates the incremental development and makes it easier to accommodate the new user stories or features during the sprints in this way. So this basically it can adapt frequently changing requirements. Okay. Next is, does the OCP apply only to classes or does it also relate to methods and modules? OCP apply to classes only. So this basically applies to all the software entities, including the classes, methods, modules. any unit of the code that can be extended without modification while maintaining the existing functionality follows the OCP. So it not only for the classes, also for the methods, also for the modules. Okay. Next is, how does the OCP relate to the use of design patterns in software development? So many design patterns such as the strategy pattern, decorator pattern, factory pattern, observer pattern. So all those adapt the OCP by allowing to extend the functionality without modifying the existing code. So design patterns generally provide practical ways to implement the OCP. Okay. What is the main goal of the open close principle? So the primary goal is like encourage the code extensibility and maintainability. So already I have told that open for extension but closed for modifying. Okay, so it allows us to add the new features or behaviors to a system without having to modify existing or working code. So it basically reducing the risk of the introducing bugs. Okay, so we will do the modifications only when in that particular class or module, suppose some bugs introduced. For that case, we will just modify. So the main goal. That also we have discussed. Next is like, does applying OCP mean that no code modification is allowed on once a class is defined? So OCP means no code modifications once class defined. So no, OCP does not mean that the code should never be modified. So it suggests that modifications should be limited to fixing the bugs or making the essential improvements, not for adding the new features. So for new features, you will not modify any class or module. Okay. So that's why when it's like you need to calculate the area for the circle or rectangle, you are not modifying any classes. So this is permanent. Okay, so you will just make new class, make the unique responsibility for that, single responsibility for that, and then you will use the final class. Okay, you will use the same interface, or you can implement that same interface for each class, and finally you keep one class that will return your result. Okay, so this is basically the O for the open close principle. Next we will discuss about the L for Liskov substitution. Okay, so that's for now. So thank you for watching, and again we will discuss in the next lecture. Thank you.